So yesterday we studied how to read a ZY Smith chart, right? So this is the ZY Smith chart. We saw how to read a ZY Smith chart. So let's start with the matching using LC section. So the numerical is a load, Z load. We write this here Z load because we are using ZL for inductance or impedance of an inductor. So Z load, if you write ZL also it is fine, equal to 10 plus J10 ohms is to be matched to a 50 ohms line. Design two matching networks at a frequency of 2 MHz. So as we saw in single step and double step matching, we have two solutions. In the same way, here also we have two solutions. So they have asked both the solutions. So how to tackle this? So first what we do, since we are using Smith chart, so we'll write it is Z load bar. So what will it be? Z load upon Z naught. Z naught is what? 50 ohms. So you write the steps. I will not write the steps. So 10 plus 10 I, correct? Yes, divided by 50. So it is 0.2 plus J 0.2. Again, no unit because impedances are divided, so no unit. Right? So first step is to plot this on the Smith chart. Right? So resistance is what? 0.2. So this is when here it is increasing, here it is decreasing. So 0.2 is this circle. So I come here and this is 0.2. Fine. And remember we are using as impedance Smith chart. So from normal Smith chart you can see that 0.1, 0.2, 0.3 goes like this for impedance. So this is the way we have to go. So this is what? ZL bar. Right? And what we have to do? So if you observe, I'll give the example of single step matching. In single step matching, what we did, this was our load ZL, this was the step, sorry, right? So we are matching it to Z0. So in normalized form, this was Z0 and this was ZL bar. So you are matching ZL bar to 1 plus J0. So this is the way we had matched, right? So in the same way, we have to now match Z load bar with 1 plus J0. So where is the 1 plus J0 point? It is this point. So somehow we have to bring this point over here. So how to bring that? That we study in this matching technique. So that is the numerical actually. Okay. So what we do is, let's say this is point A and we have to match point A with point C. Okay. So there are two solutions. So let's see the first solution. Okay. So the matching is quite simple here. We have to just remember two things. We will only move either on the constant conductance circle or on the constant resistance circle. So again, which is the constant resistance circle? This is our constant resistance circle for R equal to 1. This is constant conductance circle for G equal to 1. So this is for impedance Smith chart. This is for admittance Smith chart. Right? So dotted lines indicate constant conductance circle. Solid lines indicate constant resistance circles. Right? So I can move on which circle here? Here I can move along the solid line here. So I can move along this solid line, which is a constant resistance circle, right? So I'll use a red pen. So I can move like this, but I cannot move like this. I have to match to this point, right? So if you observe, if I am moving like this, and if I move along the dotted G equal to 1 circle like this, both are intersecting. So I don't consider this. I go like this along the constant resistance circle, then I move along the constant conductance circle. So if I travel this way in this direction, what is happening? From point A to point C, I am going through a point B and I am getting matching, right? So what we have to do, there is a difference in this reactance, find them and check whether it is an inductor or capacitor. So this is the way we achieve matching. As I told, it is quite simple. So what to do? So for that you have to remember four simple things. If we are moving along solid line, we are in series. Why? Because along a solid line means we are using constant resistance circle, that is on impedance Smith chart. If we are moving along dashed dotted lines, we are in parallel because it is admittance. And if we are moving upwards, it is an inductor. If we are moving downwards, it is a capacitor. Okay. So from A to B, we have moved where? Upwards. So it is what? Inductor. And if you check, it is a solid line. So it is what? In series. Correct? Yes. So let's draw the diagram now. So we have a load Z load. Fine. And this is which point corresponds to point A. So point A to B we are going upwards. So it is an inductor and we are moving along solid line again. So it is in series, right? So series inductor. From which side? Load side, remember. From which side? Load side, remember, right? So from here we are encountering inductor. Now we are going downwards. So it is a capacitor and along dotted line. So parallel. So one thing you have to remember is, if one element is in series, the next element should be in parallel only. Okay. So here we will achieve 1 plus J0. Okay. So next step is what? To find L and C. Right. So how to do that? So for that I'll use a green pen. So now if you observe this reactance, remember I am saying reactance because for this A to B we have moved along impedance mixture. This is 0.4, J.4, and this is what? J.2. Again, you may not see here, so while solving, or you take your own Smith chart, then you will understand, right? So this is what? An inductor. So impedance will be what? XL, right? Or we can write small ZL. It is what? What is the difference? It will always be destination minus source. That is from B, that is B minus A. So you have moved from A to B. B is the destination, A is the source. So take the reactance of B. What is it? J.4. So J.4 minus reactance of A is J.2. So J.2. So therefore ZL equal to J.2. Correct? Right? Next, we have moved from B to C. So destination minus source. And what is it? A capacitor. And we have moved along which line? Dotted line. So it is an admittance. This is very important. Again I am repeating, we have moved along a constant conductance circle, right? Because it represents a dotted line, so admittance mixture. So it will give us what? Admittance. And it is what? Admittance of capacitor. So YC, small yc, equal to, it is in normalized forms. If you want, you can give bars. So YC bar will be what? These two reactances. This reactance is what? Susceptibility actually. So this is J0. So J0 minus, what will next be? This. Now we saw impedance, so we saw it like this. For admittance, what will we see? Dotted lines. So dotted line is not going like this. For this point, it is going like this. So I'll use a brown pen. So it is going like this. So it is around J point, no, J2 it is. So from here it is decreasing. So this is 4, sorry, this is 0.3, this is 0.4, this is 0.5 for impedance. So above it is written 2.0, above 0.5 it is written 2.0. So this is the admittance of dotted line. So J2, and it will be what? Negative, that we saw yesterday. Where is that page? Yes. So this is our ZY Smith chart which we saw yesterday, right? So what are we doing? We are in which part? Upper part, right? So what is it? For this part, when we are considering admittance, we use this thing. For impedance, we use this thing. So this is positive for impedance, negative for admittance. So this reactance which we got minus, sorry, J2, it should be what? Negative, because we are considering admittance mixture. So minus of minus J2. So therefore YC bar equal to plus J2, right? So next step is to find the value of inductor and capacitor, right? So again I'll write ZL bar equal to J.2, and what we have got? YC bar J2, right? Now what is ZL bar? It is nothing but XL bar, reactance of or impedance of inductor. What is it? J omega L. So J omega L equal to J.2. So therefore L will be what? 0.2 upon omega is 2 pi f, and f is given as 500 megahertz into 10 raised to 6. But I made a mistake. It is in normalized form, so we have to convert it to denormalized, right? So ZL bar is what? ZL by Z0. So therefore ZL by Z0 equal to J.2. So this is what? 50. So when it goes here, ZL equal to J.2 into 50, so J10. So now you use omega L equal to J omega L equal to J10. So therefore L equal to 10 upon 2 pi into 50 into 10 raised to 6, 500. So 10 upon 2 pi into 500 into 10 raised to 6. So therefore L equal to 3.183 minus 9, so nano Henry. So this is the value of inductor. So what will be capacitor? It is what? YC bar, right? So what is it? YC bar, remember, right? So for that, let's do one thing. So if we have ZL bar, what we write? ZL by Z0. So I want YC bar or YL bar in one way. So YL bar will be what? Inverse of this. So I take inverse on both sides. So 1 by ZL bar, which is YL bar. So this will be Z0 by ZL, inverse of this. What is Z0? 1 by Y0. What is ZL? 1 by YL. So if you solve this, this is 1 by Y0 divided by 1 by YL. So you know from basic mathematics, this will be 1 by Y0 into YL. So YL by Y0. So therefore YL bar equal to YL by Y0. So what will be it in terms of Z0, because we know Z0, YL into Z0. So this is very important. So therefore what will be YC bar? Sorry. So YC bar is what? What is YL bar? YL into Z0. So what will be YC bar? YC into Z0 equal to J2. So therefore YC equal to J2 by 50. And what is YC? XC is what? 1 by omega C. 1 by J omega C. So what will be YC? J omega C. So J omega C equal to J2 by 50 is 25. So therefore C equal to J will get cancelled. So 1 upon 2 pi into 500 into 10 raised to 6, and I forgot this 25. So 25 into 2 pi into 500 into 10 raised to 6 inverse. It is 1 by, right? So this is in 10 raised to minus 12. This is, since you are in complex mode, engineering won't work. It will give I. So you have to do it manually. So convert it to picofarad. Don't keep like this. So it will be what? 12.7 into 10 raised to minus 12. So 12.74 picofarad, right? So we are done with one solution. So is that pH? Yeah. So L is how much? 3.183 nano Henry. So 3.183 nano Henry. C is what? 12.74 picofarad. So 12.74 picofarad. So if we use this combination with ZL load 10 plus J10 ohms to connect a series inductor capacitor in parallel of this value, here you will obviously get 1 plus J0. So you can calculate using impedance calculation series parallel, which you have studied in CTL, circuit theory or network theory, whichever was the subject, and you can cross verify. I will not do that you can do yourself. Okay, so let's do the second solution. So here what we did, we went up. Now what will we do? We'll go down. So there are two ways, right? Now I use a green pen. I'll use red only. So here we went up. So we went like this. But what we can do? We can go like this downwards also. Why go only upwards, right? So I go like this. Again I am moving along solid line. So I can keep moving here till I reach G equal to 1 circle. So I can come from here like this. This I am drawing just for explaining. So you can do like this directly. So what I am doing, I am moving from A to some point now, let's say D. So I am moving from A to D, then D to C. Right? So this way I am getting. Fine. And here I have moved along constant resistance circle. So again we require the network. So I will draw it here. So again we have Z load here, and let's see what elements we get. So we are moving along constant conductance circle, constant resistance circle. We have moved along solid line. So it is in series, and we are moving downwards. So downwards, so capacitor. So series capacitor. So next we should obviously get an inductor. Let's check. We are moving upwards. So we are getting inductor and along dotted line. So it is what? Parallel. So that's what we are getting. I told you if one is in series, next will be other element and in parallel. So we have to find this L and this C now. Right? So obviously the values will change. Right? So next step is what? Again I'll use green pen to find the reactances. Right? So for here we have moved along which circle? Solid. That is constant resistance circle. So we have to see solid line. So for this point I am coming here. So it is J.4. And this point we already know. For solid line it was this J.2. But destination minus source. Right? And it is what? Capacitor. And along solid line. So ZC bar. Right? ZC bar. What is it? This is J.4. But we are in impedance Smith chart. So impedance is negative in this part. So this is minus J.4 minus destination minus source. So this minus is destination minus source wala minus. So here this is what? Again impedance. So this is what? J.2 positive only. I mean the reactance is positive. So therefore Z, this was C. So ZC bar equal to minus J.6. Right? And we have, you can check in this way also whether you are correct. Impedance of a capacitor. What is impedance of a capacitor? Is it negative? Yes. It is negative. So we are correct. Right? So then we'll solve this. So let's solve this now only. So ZC bar is 1 upon J omega C equal to minus J.6. So minus, this is also minus J. So this will get cancelled. So C will be 1 upon 2 pi into 500 into 10 raised to 6 into 0.6. 2 pi F. C will go here. 0.6 will come here. So equal to, so 1 upon 2 pi into 500 into 10 raised to 6 into 0.6. So it is 50.53 nanofarads. Okay. So equal to 0.53, what is it? Minus 9. So nanofarads. Oh, again I made a mistake. What mistake I made? This ZC bar. So we have to denormalize it. Sorry. So ZC bar is ZC by Z0 equal to minus J.6. So therefore ZC equal to 50 will come here. 6 into 5. So minus J30. So ZC is minus J omega C equal to minus J30. So I'll directly write C now. So therefore C equal to 30 divided by 2 pi into 500 into 10 raised to 6. So 9.55 picofarads. So this is the value of C. So for L, what will we do? We went from A to D. Now we have to go from D to C. So destination minus source, C minus D, and that is what we are going upwards. Inductor in along dotted line, so parallel. So YL bar. So while bar equal to, what was it? Okay, we have to find. So this is what J0 minus. For this, it is admittance, remember. And admittance is what in the Smith chart? Admittance is positive. So there is a simple way. You know impedance is positive here, so capacitance will be negative. Sorry, impedance is positive here, so admittance will be negative. Impedance is negative here, so admittance will be positive. Right? So J0 minus J. So here we are confused whether to take 0.5 or 2.0. So as I told yesterday, take a normal Smith chart. Here what you know, 0.1, 0.2, 0.3, 0.4, 0.5 decrease हो रहा है, right? So 0.2, 0.3, 0.4, 0.5 is decreasing. So there is another number here, 2.0. That is for admittance. So I'll draw that with green pen. So J 2.0, right? So J0 minus J 2.0 or minus J2, and admittance is what? Negative. Why negative? You can say impedance is negative, so sorry, positive. Impedance is negative, so admittance is positive. So I have taken positive. This minus is destination minus source wala negative. So therefore we have to convert it to normal. So YL into Z0 equal to J2 minus J2, and YL is what? 1 upon omega L. So JJ will get cancelled. So 1 upon omega L into 50 equal to 2. So solve this. L equal to, let's see, yeah. This is minus. So JJ will get cancelled. So L will be 25. 50 by 2 is 25 upon 2 pi into 500 into 10 raised to 6. So 7.96 picohenry, right? So this is the final network which we have to do. So L is 7.96 picohenry. C is 9.55 picofarad. Fine. So this is the way we have to solve. Okay. So in the exam, usually they ask only one solution. So you have to either take this one or this one. So depending on the solution, your answers will be different. Okay. So again, I'll tell in a jiffy what we have to do. First, solid line if you move, it is series. Dotted line if you move, it is parallel. And if you are moving upwards, inductor. If you are moving downwards, capacitor. So this is the point we mark, ZL bar, right? Or Z load bar. So from here we can go upwards or downwards along a constant resistance circle. If you have a doubt that why we don't move along with the dotted line or constant conductance circle, you will move, but you will move like this. So you are not encountering this point. You want to come at this point, so better take this one. So we draw this line. Then we know we have to come from here to here because we have to match to 1 plus J0. So we consider this line. Then we see they intersect here, so we take this point, and then we just find the reactance. And what do we remember? Impedance here is positive and impedance here is negative. So if we are taking admittance here, it will be negative, opposite of this, and admittance here will be positive. Why? Because impedance, suppose it is J. In admittance, what will it become? 1 by J. So minus J. So plus is changing to minus. So in the same way, minus will go to plus. That is the reason if this is positive, this will be negative. If this is positive, this will be negative. Okay. So this is the way you have to solve. Thank you.